in the previous lecture we completed out this bird class, which will be completely having just update to change the position of the bird, and this property to deal with the image and make a rectangle and to mask the image. So in this class or in this lecture, what we're gonna have is next class, which will be just gonna give a name as let me say Pygame. Let me say it is a Pygame, and just import, that is it should be inherited from the parent class. So sprite.sprite, so is to use this class method. So what we're gonna do here, so firstly this method, this class is really important after the bird. So it represents, basically this class represents obstacle for the bird, obstacle obviously, that is the pipe. And so pipe here has a top and bottom, and you can say bottom, and only between that top and bottom the bird can pass. That is the rule, obviously you know the rule of a Flappy Bird, and if it collides either of the part of this pipe, game is over. So let's define the attribute first. So what this can be attributes, let's visualize it again. So obviously one can be the x, this is the x position, because the pipe here also moves in a x position, and there is no y attribute, no y. Why there is no y? Because it will always be 0, so there will be no movement for the pipe in this direction up in y, it will just move in right direction. Pipe will come from here and bird will move from here. So that means what we're gonna do, so next will be image. Obviously image will be important because we have here the pipe image and pipe body and pipe end, and similarly that will be the three images that will be important in this class. So we'll just deal with that images, and similarly we'll just have a marks like here, that is we have here in the case of the bird will also marks. So marks is basically a bit marks which excludes all the pixel in the self.image with a transparency greater than obviously 127, like that was in the case of a bird. And this can be used also for the collision detection if the basically bird hits this pipe. So what we're gonna do here is now we'll just define some of the attributes here, and more attribute can be something that is top pieces, and let me say it is top pieces, and this top pieces is the number of pieces including the end pieces in the top pipe. So that means we have here top pipe, let me say, so here's a pipe end, so it should be pipe end, so this is also a pieces, so including the end pieces it will have the all the number of pieces. So this top pieces is number of pieces including the end pieces in the top pipe. So this is the top pieces. Similarly we'll have a bottom pieces like is top pieces, so that would be bottom pieces, and this is also the number of pieces including the end pieces in the bottom pipe. So we'll have now constants. So we have now finished with the attribute. Now we'll see about the constant will be obviously the width. This width is the width of a pipe piece, and similarly we'll have piece height, and this height is basically the height of a pipe piece in the pixel, and we'll have add interval, and this is important, add interval. So what is this constant add interval? It is the interval between the adding new pipes in a millisecond. That means when you have two pipes, so this is the interval between the adding new pipes in the millisecond. So when you add new pipes, because we have this frame, and in this basically screen there will be adding of a pipe, so that will be the interval between the adding a new pipes in millisecond. So this will be in millisecond. So these are all variables and a constant. So let's define now class. So for that we have now first width, obviously width of a pipe, and that would be 80, and piece of height, and let me just give underscore here, and piece of height let me say 32, and similarly add interval. I've already said you what the add interval is. It is the interval between the adding new pipes, and it should be in millisecond. So add interval should be 3000 here, and it is in millisecond. That means you have something 3 seconds. So you can always here, you can always play with this number, so change accordingly your need, and it doesn't really matter here. So just make the game challenging. So that is the main purpose of these points here, that is with these numbers. Now what are you gonna do? So first will be always the function, that is the init function. So init function is the constructor that will just initialize all our variables of our class. So what we're gonna initialize here? So first will be pipe int img image, that is the pipe int image, and similarly we have pipe bird image, and these are the two images, and this will initialize a new random pipe pair. This function will initialize us a random, this is the random, and this will be pipe pair. That means the distance can be edge here, basically in the case of there, let me see, it should be in the case here. So this should be 32, that is the gap between the pipe, but the length or basically the width of the pipe can be random here. So this is the purpose of init function. So let's define this init function first. So in this init function, what we're gonna have is we're gonna have a pipe pair, and that will be automatically assigned an attribute of float. So let's see what is it going to have. So firstly it will just see here self dot x, and this self dot x will be float, and win, that is the window width -1. So this is a random. Basically what this really means is it has basically initialized as a new pipe pair, which will be automatically assigned as an x attribute here of a float win width -1. So this is the purpose of using this statement. And similarly what we're gonna do next is we haven't yet counted the score, so we'll say self dot score counted. Score counted, it should be called when we just create this method. So basically score counted here, so UN counted, score counted the function. So this score counted should be false. And what we're gonna do next is self dot image. So just assign the image now, that should be Pygame. Under this Pygame, let us define a tuple. So that would be pipe pair, obviously this pipe pair dot width, and will be something that is win height. This is the basically window height that we assigned previously in here in the base variable, that is a 512. And similarly what we're gonna do next is we're gonna outside this tuple we're gonna have src alpha all in capital. This is the constant. So this is basically for the transparency on the background, so it will just create a transparent image for us basically. So what the next? So we'll just convert that image like in the case of the bird. So that will be from this function, that is a convert function, and this convert will basically speed up the bleeding. So just bleed now, so not bleed, we'll just fill first. So self dot image dot fill, and what the color it should fill. So just to give a tuple here, that is the RGB value. So let me see 0 0 0 and 0, that is for the white. So what you're gonna do next is let me say total. Let me just create a new variable here, that will be total pipe body pieces. So this basically, let me just complete with my statement here first, and I'll show you what is going on. So first will be win height and minus. So what this basically does is, let me just give here a space, and this is basically when you fill the window from top to bottom. So this is the case. So let me just see here win height first, and before this win height you have here let me just create another opening parenthesis, and let me just complete my statement here. That is the 3 multiplied by win height, that the third times the win height. This is basically to fill the window from top to bottom, so this will make our room for the bird to fit in the basically in this screen. So let me say it is height minus, and again let me create the 3 times this, the pipe here dot, we have piece height, and after that attribute let me just close it and divide. Now let me divide with pipe here dot piece height, and this will be our completion. So what is this really doing? So this will just fill our window from top to bottom. So this is the purpose. So we haven't used this total pipe body pieces yet, and we'll use this here. That will be like self dot bottom pieces. Let me create another here as a bottom pieces, and should be integer, that is a random integer from 1 to this total pipe body pieces. So it should be from here to total pipe body pieces. That means we have here an integer, and this integer is basically getting us something, that is the pipe pieces, and it is not restricted to basically bottom or restricted to top. It can be used for both top and bottom. So we have used for the bottom, so let's make it used to top too. So let me say it is a top pieces again of this current object, and just give the random int, and it should be 1 comma total, again the pipe pieces. So these are the 2 important that we created now, the bottom pieces and top pieces. And now let's use that basically for the bottom pipe, and similarly for the top pipe. We have the 2 portion to delete now. So firstly we'll go with the bottom pipe. So in the bottom pipe, I in range, let me give the range from O to let me say it should not be O, from 1 to, and we'll just add it now. So self dot bottom pieces that we just created here, that is a bottom pieces plus 1, that we started from 1. So if you started from O, then that can be 0. So 0 is here restricted, so we'll just start with 1. And what we'll do next is piece position. We'll just create a new variable as a piece position, that the current position for this bottom pipe, so it's to distribute in our screen. So that would be something that is a O comma win height is basically our height, total height of 520, minus I times let me say I times pipe here dot piece height. So this is important, piece height. After that what we're gonna do is we'll just bleed this image. So we have got this image, now we'll just bleed it. So self dot image dot bleed, we have bleed function here, blit bleed, and bleed, what you should bleed is pipe body image. This is to bleed, and give the position, that would be piece position that we just created, that the piece position, and just bleed it there. So this is for the bottom pipe. Now what you're gonna do next is, so after you bleed this image, that is the pipe body image here in this position, now we have to bleed, that is the pipe end image, that is this pipe end image. So in order to bleed that, what we're gonna do in the bottom pipe is, we'll first check for this bottom dot pipe, and let me just create a new variable again here, that would be end, and let me just check it, it should be outside this function because we have already bleed, and that is the pipe body. So I'll just outside this for loop, we'll create a bottom pipe, it is a bottom pipe, and end y, let me say end y. So this should be initialized as something that is a win height, that is our complete height of a console, and minus self, that is our current object, and bottom height, let me say bottom height pixel. So bottom height, and it should be pixel px. So let me see, and it is showing us unresolved reference because bottom, it should be bottom height pixel and win height. So let's just keep it as the reference here, and just will now create here bottom and end pipe position, that is end pipe position. So this will be something that is inside this bracket. You can just give a range here, that is 0 to, so this is basically a vector that we are creating. So it should be bottom pipe end y, that is this value that we created, and similarly we'll say that is pipe here get me the pier piece height, and you can just subtract it from here. And after that, what you're gonna do is we'll just bleed now. So that would be self.image.bleed, and that would bleed our pipe end image, that we get the position from this pipe end position, that is the range from which we divide minus this win height and bottom height pixel. So what you're going to do here is bottom in position, so this should be bleed, so this end pipe end image should be bleed in this bottom end pipe position. So now we have covered this bottom pipe. Let's go to top pipe. So let's see what is top pipe is all about. So for same as here, like here we have range, so I'll say for I in range, that will be self dot, obviously you have guessed this is a top pieces. So this is the top pieces. What you're gonna do is self dot image dot bleed now, and that what should we bleed? Obviously we'll bleed the body first, and this body should be, where should be it bleed? So give the vector here, should be o comma I into, that is the I is the range basically in this top pieces that we created basically here. Maybe is top created is created here from the random range, and it should be I multiplied by, let me say pipe here dot piece height. So this is basically for our bleeding this body. Now what if we want to bleed the end now, this one? So in order to bleed that, go outside this for again and just create something that is a top pipe and index, same as in y will create index, and that would be self dot top height pixel and top height px pixel. And similar what we're gonna do here, self dot image now, and just bleed now. And what to bleed is to pipe end, not body. Now it should be end image should be bleed. Where it should bleed, it should be 0 to, in this not range, this is basically vector, this is basically position where it should be bleed. So it should be index, this total pipe index. So we have created now the bottom pipe and top pipe. Now we'll compensate for the adding the end pipes. So we'll created this top height pixel and bottom height pixel references. So let me say it is the for the compensate for added end pipes. So here we'll compensate for the adding the end pipes. So that will be self dot top pieces will be added here equal to 1 with this unit increment, and similarly bottom pieces, same goes with bottom pieces. Let me say it's bottom pieces, add it as increment by 1. So now we'll just detect the collision, that is detect collision. So let's detect collision, that is for the self dot marks, and I have already told you this marks was used to detect the collision. So I'll say if the Pygame, just first will use this module to use this marks, and we have something that is a from surface. So this from surface will just take our image, that is our tuple, and it will take our image, and we have now collision detection. So we have completed our init method of this class, which is PyPeer class. So we have to deal with the bunch of properties in this class now in the next lecture, and then we can just create the instances of a bird and we can run the game.